All right, welcome to Monday of our second week. If you have not printed off the PDF notes yet for the week, go ahead and do that. And again, if you don't have a printer, you won't need them, but they would be really helpful. And then let's jump in and take a look at what's going to happen this week. All right, so taking a look at our calendar for the week, Monday, today, we're going to look at 9.6, and we'll do that for Monday and Tuesday. We're going to continue there, and I'll explain that more as we go. Now, Wednesday, Thursday, and Friday, we're going to be doing the same thing for all 3 days. We are going to begin reviewing Chapter 9. Now, Chapter 9's been a chapter we've been working on since before we've been working from home. Okay, and so we're going to do this review much the same as we normally would, so I'll quickly explain what that'll look like. First of all, in that PDF, there is the review, okay? And you're going to have 3 days to complete the review. And I kind of made these check boxes for you to follow. You're going to complete the review. You're going to submit it by taking a picture. And there's 3 sheets that go with that. All right, so you'll submit that to me. I will then email you the answer key. So once I've seen that you've done it, I'll give you the answer key just like in class. Remember, you would show it to me that you finished, and then I would give you an answer key. That's what we're going to do again. You're going to check it. You're going to figure out any mistakes. Let me know if you need any help with that, and do extra practice if necessary. Right now, we're planning to have our Zoom meeting at 10 a.m. on Thursday to go over any questions you have there, and we'll also record that in case you can't make that meeting. And that is not necessarily a mandatory meeting, but it'd be a great time to come and get your questions answered. Obviously, it's all online, and I'll get you more information, hopefully Tuesday, about how to join that meeting. So you guys have 3 days to complete it. We are looking to have our test over Chapter 9 next Monday and Tuesday. You're going to have at least 2 days to complete the test. With these 3 days here, could you do the review all in one day? Yes, but I'm only going to give homework, right, that takes a half an hour each day. And so you can't do it in a half an hour. So I've given you an hour and a half. I don't think it'll take most of you that much time, but I do want to leave the flexibility there in case it does. I believe it's 34 problems, 35 problems. Just a few notes about this. I split this up by section, and I also split it up by objective. So if we take a look at the beginning of it, first of all, you guys notice that this says Wednesday through Friday, okay? And then we have these goals. I can identify parts of the coordinate plane. I can graph points on the coordinate plane. Once you've checked this, and if you got 100% on this portion, you would say check, check. I can do that. Then coming down here, I can find the domain and range of a relation. You'll do a problem of that. If you get it right, you'll be able to check it off, that you know how to do that. If it's not a place where you can check it off because you get it incorrect, that might be an area for extra practice. All right, so let's jump in with all of that. We are going to be working on that review later in the week, but for today, let's jump into 9.6, a deeper look, day 1. All right, so let's jump into 9.6, a deeper look. We are going to continue to be in 9.6. There are some things that we haven't gotten to yet that we need to see. Technically, I would say you have all the tools to do these problems, but when we are so far apart and not being able to ask questions very easily, I wanted to show you some more examples, work through those together, and give you similar homework problems. So for the next 2 days, we're going to continue in 9.6. So first of all, with example 1, it says using the XY intercept method. Remember, to use that XY intercept method, you guys have all the notes for this. To find the x-intercept, we know what about a point on the x-axis. We know that the y is 0, and for the y-intercept, we know that the x is 0. Okay? So we plug those in, and we'll have our answers. So let's plug 0 in for y. Remember, it's x, y in the point, so we're going to plug 0 in for y. We have negative 2x plus 3, and instead of y, we're putting 0. Equals 6. 3 times 0 we know is 0. So we have negative 2x equals 6. Be careful. I noticed a lot of you are losing your negatives. All right, so you're treating this as a positive 2x, but it is indeed negative. So to get x by itself, we divide both sides by negative 2, and x equals negative 3. So when y is 0, x is negative 3. And now we're going to find our y-intercept. Same thing, except we're plugging 0 in for x. Negative 2 times 0 plus 3y equals 6. Negative 2 times 0 goes away. 3y equals 6. We divide both sides by 3. And y equals 2. So when x is 0, whoops, y is 2. Sorry, I kind of goofed that up. So it's 0, 2 there. So we go to plot our points, negative 3, 0. So negative 3, now first of all, that's the x. So on the x-axis, if it helps you label them x and y. So on the x-axis, we're going to go back 3, and then it's 0. So it is on that x-axis. And then our y-intercept is 0, 2. So 0 on the x, 2 on the y, and we have our line. Now you're going to pull in that straight edge. I've noticed a lot of you are not using a straight edge. Please do that. It is not optional. I've been gracious as far as some things, but that needs to be happening or else I'll be taking points off. So make sure you are using a straight edge. We're getting a straight line. Make sure it extends past the points and then arrows on both ends. All right, moving to example 2. Now we're going to graph this using the slope-intercept method. Remember, the first step in the slope-intercept method is to make sure that y is by itself, okay? From here, we are now going to identify our slope, and remember we can use m for slope, and we're going to identify our y-intercept. Now we know whatever is being multiplied to x is the what? You need to look back at your notes, look that up. Anything, or whatever's being multiplied to x, now that y is by itself, is what? And you should be saying it is the slope. And if I'll write that in over here, slope equals m equals negative 2. All right, now the y-intercept. We know in the y-intercept, what do we know about the y-intercept? That the x is 0, and we know that this constant term over here is the y-intercept. From there, what do we deal with first, the slope or the y-intercept? This is a really important part that a lot of students miss. What should we be dealing with first? We should be dealing with that y-intercept, right? So we're going to go in at 5. So 0, 5, so 0 on the x, 5 on the y. Okay. And then my slope, remember we changed that to fraction form, so negative 2 means the same thing as negative 2 over 1. Could we say it also means the same thing as 2 over negative 1? Do those two mean the same thing? They do, and I'm going to show you why that's helpful. So using negative 2 over 1, slope, remember, is rise over run. Now, think about this. Negative 2 over 1, rise over run. Now, does rise always mean go up? No, it simply means up or down, right? So if it's a negative 2, will we go up or down? We are going to go down, right? And if it's a positive run, will we go left or right? We will go right, okay? Because on the x-axis, if you go to the right, it goes positive. And if you are on the y-axis, it goes down for negatives. So from our y-intercept, we are going to go we're going to go down 2, rise, down 2, run 1, down 2, run 1. Now, we can continue going like this. You should have at least 3 points if they'll fit. More is better. Now, if we look back up here, instead of negative 2, 1, what if we did 2, negative 1? Let's talk about that. So 2, negative 1. Now, positive 2 would mean up or down? It'd be up, right? And negative 1, would that be left or right? The negatives are left, right? So what if we did this? Up 2, back 1. Would that fall in line as well? Yeah, so we can do down 2 over 1, down 2 over 1, or we can also do up 2, back 1 by flipping the sign from the numerator to denominator. These mean the same thing, and they're all part of the same line. So from here, go ahead and use your straight edge. Draw that straight line in, arrows on both ends. Okay, let's move down here. Again, we're using slope-intercept form, so we need to identify the slope. We need to identify the y-intercept. The slope here is that number being multiplied to x, 3 over 2. Now we go, and first of all, I should have mentioned, the y is by itself. Tomorrow we're going to see problems where the y is not by itself, so it does matter. But in today, you'll notice the y is by itself. Now, the slope is 3 over 2. Now, is there a constant being added on this right side? Is there a constant being added on the right side? No. So what is the only thing that you could put in here that would mean the same thing? The only thing you could put in here, plus 1 wouldn't mean the same thing, plus -1 wouldn't mean the same thing, but plus 0, right? That would mean the same thing. So when you do not see a y-intercept, it means it is 0. Okay? So remember, 3/2, rise over run. It's already in fraction form. Remember, we start by graphing the y-intercept. And if we want to put that as a point, we know if it's a y-intercept, the x is 0. And then according to this, the y is 0. So we have that point 0, 0. And then these are both positive, so it's going to be up and to the right. So up 3/2. So up 3/2, up 3/2. We can also do the other way, right? Think about this. Why is that possible? Well, if we have 3/2, does that mean the same thing as -3/2? It does, right? So could we go down 3, back 2, down 3, back 2, right? That does mean the same thing. So notice, if it's one negative, if the number is negative, we can switch it from the numerator to denominator, like we had up here, okay? If it is positive, we can make them both negative and it means the same thing. So I'm going to grab my straight edge, draw my straight line in, and we are going to move to example number 4. Make sure you're getting those arrows on both ends. Example number 4. Now this one looks very, very different. We're going to be graphing using the slope-intercept method. So let's just set it up the same way we have. Slope equals y-intercept equals. Okay, now we know that the slope is the number being multiplied to x, and the y-intercept is the constant. First of all, notice y is by itself, so we're ready to go. We have 5. Would that be the slope or the y-intercept? Well, is it the number being multiplied to x, or is it the constant? And in this case, it is a constant, so it's the y-intercept. What is the only thing we could have for our slope here that would be true? We can't see it, so let's draw this out. Y equals, it's a +5, so +5. We have our x here. What would we multiply x by in order for it to go away like that? The only thing that would work here is 0x, right? Because it would disappear and we just have y equals 5. So if we do not see a slope there, we know if we don't see anything being multiplied to x, we don't see that x, then the slope is 0. Okay, so when we have y equals 5, we have a y-intercept of 5, so that means that the x is 0, the y is 5, and the slope is 0. So let's take a look at that. 0, 5. So if I come over to my graph and I plot this y-intercept first, 0, 5. Okay. Now, if I have a slope of 0, is there going to be any ups or downs? No, we know a line with the slope of 0 is completely horizontal, right? We talked about this before back in our slope section. Now, if we did want to change this to fraction form, would it be 0/0? No, it would be 0/1, right? So we would say up 0, run 1, up 0, run 1, up 0, run 1. We could also say, we could also go in the other direction as well. And we can see that we are forming this vertical, or this horizontal line. And arrows on both ends. Anytime you have y equals some number, it is a horizontal line going through that number. So if we have y equals -2, it's going to be a horizontal line going through -2 on the y-axis. Okay, tomorrow we're going to see problems where they say x equals something, and we'll talk about how to deal with those then. So that is our lesson for today.